Okay, so what I'm doing right here is we just I just want to hit home of what we learned yesterday. So we're speaking about stellar stack, and the stellar stack has four different layers. And I just want to make sure everyone understands uh, what happens in all these layers. At the very bottom is the network layer. That's where all that's basically the backbone of everything that's happening in the stellar blockchain. For example, the software itself, the stellar consensus protocol, and it's basically the backbone of the stellar network, the stellar blockchain network. And when we go to the second layer, that layer is the data availability, and we can see some of the components like the RPC, the horizon, the indexes, and the hub and hubble. So these layer provide access to network data and smart contract interaction. So it makes it easy for us to interact with the blockchain itself. We spoke a bit about the horizon. So the horizon, yes, I will. I will. The Horizon RESTful API. We also spoke about the RPC. So the RPC uh, serves helps us to interact with the Soroban smart contract. And the Stellar Development Foundation also offers free endpoint for the TextNet and the FutureNet, but on the mainnet, you require a private instance or an ecosystem provider to be able to use it. We're not going to go into Hubble, we're not going to go into indexes, but these are basically some other tools that is used for querying for and analyzing ledger data. And the third layer is a developer tooling. So the developer tooling is where there's all those tools that we use, all the tools that developer use to uh, build smart contract on Stellar. It basically simplifies the building of smart contract or any application on the Stellar network, and it uses the RPC. So if you use the SDK to build a smart contract, then the smart contract gonna need to, in order for it to interact with the core protocol or the blockchain itself, it has to go through the RPC. So the RPC serves as a door to interact from smart contract to interact with the blockchain itself. And then we have the last layer, the application. So the application layer is a front-facing layer where we have, for instance, we have wallet selector, anchor platform. So these are user-facing layer for interacting with Stellar. And for example, you can use your wallet to send XLM to a business or to making some transactions. So that happens on the top layer, the application layer. Does it make sense so far? Hope it makes sense. Okay. This is where we left off yesterday. I mean, this is what we were talking about yesterday. So now let's just go to where we left off. Because now we're talking about the lumens. All right, everyone, thumbs up if you have an understanding of what the stellar stack is. So thumbs up if you have an understanding so far, if it makes sense. Okay, lumens. The lumens, also abbreviated as XLM, are the native currency of the Stellar network. It's used for transaction fees, rent, and maintaining minimum balances. So when you use XLM, for example, if you want to send some XLM to someone via wallet, there is some fees. And usually it's around 0.000 zeros and a 1 XLM in transaction. And there's also what we call, it's also used for rent. So it's used for transaction fees, rent, and maintaining minimum balances. Can someone quickly explain to me what you think about rent when we're talking about, okay, why in this case are we using rent? Why are we using XLM for rent? What does that mean? Can anybody just explain what you understand by renting?
It's great. Okay, so is it relating to borrowing and taking loans out and then loan repayment, or is it doing something on the network where you're borrowing from something, or what? Or like, I don't know. That's my guess.
So that, yeah, what you just said is it's also a very common thing that we know in the blockchain space. It's one of the use cases, DeFi, decentralized finance. So this is something we're going to be talking about. But in this case, renting is something we're gonna talk more about. But in short, when we compare Stellar and other blockchains like Ethereum, for example, in Ethereum, when you create a smart contract and you deploy it on the mainnet, it stays there forever. And it doesn't matter how useless your application is, or maybe you can deploy your application and then you don't even use it. It stays there. And you can imagine it could create some bloating in the whole blockchain system. But with on Stellar, they have this mechanism, this renting mechanism, that allows you to create a smart contract and then you pay some fees for how long the smart contract will be on the blockchain itself. So this is only for smart contract. So we can say that smart contracts are not really fully immutable, because after a certain amount of time, if you deploy your smart contract and then you pay your rent for maybe a temporary fee for a temporary rent, and then when that maximum amount of time passes, then your smart contract will be out of the database of the blockchain itself. So that's one of the differences, one of the key differences with how smart contract. Yes, you can ask the question.
Is there any evidence of the smart contract being used? Because obviously any transactions around the smart contract reference the smart contract. But then if the smart contract was used, would it then still perpetually stay on the blockchain? Or would it just be referenced that, no, there was this contract, it was executed, funds went from this person to this person using this thing as a medium of transport or medium of exchange or medium of agreement?
Can you please repeat your question?
So what happens if, let's say, a smart contract executes, and that smart contract involves funds changing hands at an event? So that event happens and funds change hands, money goes into various accounts. Let's say people put money into the smart contract as well because they wanted to be part of it.
Mm.
And then it shows now at a given period of time, the wealth is dispersed from the smart contract or does what it's supposed to do. But
Mm.
now something happened and that affected the network. So the only information about the smart contract would be referenced, but then there would be no contract actually beyond that. So it would reference the contract, but it wouldn't have anything about the contract. Is that what like how it would work?
Yes, after the renting period, your smart contract is essentially gone, and even if you reference it, you won't be you won't it won't so it'll be empty. It's not gonna be there anymore. But this is one of the thing that you also have to consider when you are building a smart contract, because we can say it's sort of also a vulnerability, right? So you have to make sure that, okay, if I build a smart contract, how long do am I going to rent it, and also make sure that uh, you you know when it's going to end. So you define it on your smart contract. When you create a smart contract, you can define exactly how long or how many ledgers you you want your smart contract to stay in the blockchain. Any other
And
questions?
just another, yeah, it did. So also, is this similar to basically the way that like funds were burnt or locked up? So your funds can be locked up. Your contract doesn't have to execute if you don't actually put enough rent in. It'll
Yeah.
basically just like not happen. You'll basically lock
Yes.
up your funds and they'll be gone.
Yes.
Okay,
Which
cool.
yes, it's not good, but yes, that's how the system was. Stellar blockchain was created. So the main reason is that way is just to avoid bloating, or you can create an application and then you just you don't care about it anymore.
Is
So
there just one last question though? Is there a way to write like a self-destruct? So basically, if the contract is going to then terminate after X amount of period, like would a clause in there be able to execute the contract before it shut down? Like, is that something that people are doing, or is it just not doing, or how does it actually violate the mutability of the contract? This is more
that,
law and other stuff,
yeah.
but
That I'm gonna have
just
to get
curious.
back to you. I'm not really
Yeah.
sure about that one.
No, it's all law, dude. That's the law side of stuff. You know what I mean? You set up a contract, it's supposed to
Yeah.
do X, but like for some reason the developer fails. But anyway, it's like we'll chat about it like when we get closer to that stuff. But thanks, appreciate that breakdown.
All right. Uh, Also another thing also you have to know about the fee structures. When you send a transaction and or when you run a smart contract, you pay your transaction fees. Uh, where do those fees go? Like where do they go? Because when you talk of Ethereum, for example, there are validators who get those fees. So those fees goes to validators. Also on Bitcoin, those fees go to validators. So it is sort of an incentive for them to be on the blockchain network. But on Stellar, validators don't get any fees. So where do they go? Like where like these are open question. Where do you think the fees go to? Where do you think those transaction fees or those rent fees or any of these fees, where do they go to? Just a guess. A guess. A guess. All right. Since there's no guess, I'm just gonna shoot the answer. Burnt. Yeah, you can sort of say it's burnt. Uh, because what happens is once those fees, also known as gas fees, they they get collected. So all those transactions are collected into a fee pool, and that fee pool is locked. and not accessible by anyone, any organization, or any individual. Even the Stellar Development Foundation does not have access to that fee pool. So essentially, you say that it's burned because no one has access to that. So yeah, that's how it works. So Stellar's native currency is the XLM. It's built-in. This is its built-in token of the Stellar network. There's no issuer or trust line required. It's used for various network fees, transaction fees, account creation, and other network operation. So let's move on to the next. Okay, transaction fees and base reserves. So Stellar requires transaction fees to prevent spam and prioritize transactions. Minimum balances are calculated uses base reserves. So we're going to see how it works. Let's go quickly to the documentation. Let me show you how. Okay, this is something. Okay, let's just wait for it to load. Okay, so I recommend you to go and also view the Stellar documentation. You can find it as developers.stellar.org because I'm not going to be able to teach you everything. There's going to be a lot of gaps. So on your own time, I recommend you also go and read the documentation. So here it shows how the fee structure works, the resource limit and metering. So let's read here. So Stellar requires a fee for all transactions to make it to the ledger. This helps prevent spam and prioritizes transactions during traffic surges. All fees are paid using the native Stellar token, which is called the XLM. So there are two types of fees on Stellar. When we're talking about smart contract, there is a resource fee, which only applies to smart contract transactions. So this is the amount the submitter must pay for the transaction to execute. This amount is based on the transaction resource consumption and the state of the network storage. So this fee includes, let's try and see what this resources fee. It depends on the following: the instructions, so the number of CPU instructions, this transaction, the number of CPU instructions the transaction uses, metered by the host environment. So all the instructions that you use, the number of CPU instructions on the smart contract, the ledger entry accesses, reading or writing any single ledger entry. So it also includes another important thing to see: the event and return value size. So the size of the event produced by contract and the return value of the top level contract function. Because when you create an application, smart contract, there's what we call event. Like for the event can be like viewing, maybe viewing some information. Or for example, let's say you create a smart contract that individuals can use to save or to pay insurance. For example, let's say a decentralized insurance application. So one event in that's a smart that one of those events can be viewing how much you've paid so far, how much you've paid on the on that smart contract. Let's say you're paying monthly. So to view that is an event. So the size of the event produced by a contract, and also the return. Like let's say you create a when you get into coding, if you have experience with writing code, you know that there's functions that return a value, for example. So that also can cost, it has a cost in it. And it also includes the ledger space rent, what we talked about. So the payment of the ledger entry, uh, all that also is included in the resource fee. So another fee, the other type of fee is the inclusion fee. So this is the maximum amount the submitter is willing to pay for the transactions to be included in the ledger. So when competing for space on the ledger, smart contract transactions are only competing with other smart contract transactions. And transactions that do not execute a smart contract are only competing with other transactions that do not execute a smart contract. So the lumens collected from transaction fees go into a locked account and are not given to or used by anyone, like we said. So here's the calculation, how the resource fee is calculated. So the transaction fee is equal to the resource fee. So the storage, when you talk about the storage, the event, and all that is the resource fee plus the inclusion fee. So together, you have the transaction fee for deploying your smart contract. And one other thing I want to speak about. Where is this thing? Okay, the effective base fee. So this is when you talk about the inclusion. So the inclusion fee is the maximum bid or the submitter is willing to pay for the transaction to be included in the ledger. The inclusion fee equals the number of operation in the transaction multiplied by the effective base fee for the given ledger. So the inclusion fee is equal to the number of operation times the effective base fee. So the effective base fee required per transaction for a transaction to make it to ledger. This cannot be lower than 100 troops. So 100 troops is just smallest unit of a lumen, 1/10 million of a lumen. So that's the minimum effective fee. Okay, so yeah, on your free time, I recommend you to go and see this because there's going to be a lot of gaps, a lot of gaps. Let's get back to our slides. Okay. So you're speaking about transaction fee. Transaction fee. The reason we have transaction fees is to prevent spam. Because why would you want to spam and you spend a lot of money, you spend a lot of resources trying to spam. So these fees deters malicious actors from spamming the network. Uh, Accounts must hold a minimum balance to cover base reserves, and the calculation of base reserve. I showed you the formula. You can find it in the documentation. All that fee structure and base reserves, you find it information documentation. Okay, we spoke about testnet and futurenet yesterday. The reset. So testnet and futurenet are periodically reset and maintained to maintain network performance and to declutter data. These resets impact developer testing. So the purpose of and the schedule of reset is so the reason why resets are done is to declutter data and and Stellar. So it happens periodically, like about 3 to 4 times per year. The testnet, the reset happens 3 to 4 times per year. But before the reset happens, you get a notification. It's notification from the Stellar Development Foundation on Discord and also on their website. So it never comes just by surprise. So as a developer, you have to understand that how the reset can affect ongoing development and testing. So you have to think about that before. You have to consider that when you are building your application and testing your application. Okay, testnet and FutureNet best practices. The best practices for using testnet and FutureNet effectively include understanding delimitation and preparing for reset. Uh, and when you are building something, you cannot. Oh, this is a question for everyone here. Let's say you are building a smart contract and you want to deploy a smart contract uh, on the mainnet. What network are you going to use to test your smart contract before deploying it to the mainnet? Is it going to be the test net or is it going to be the future net? I think this is a very easy question. Anyone? This is very easy. Can I repeat the question? Let's say you're building a smart contract and your aim is to deploy it on the mainnet, right? But before getting to the mainnet, before deploying it to the mainnet, what network are you going to use to test your smart contract to see how it works before deploying it to the mainnet? So is it going to be the test net or is it going to be the future net? Okay, thank you. No there. Test net is correct. So yeah, when you're creating your smart contract, you also have to know which network you're going to be using. Remember, the future net is suitable for testing new features that don't exist on the mainnet. But the testnet is a replica of the mainnet, so it's much more predictable. So it's the one that you have to use. Suitable use cases for testnet and futurenet. Ideal scenario for using each network. So I'm pretty sure now you understand the ideal scenario for using each network. So thumbs up if you now understand. Do you understand the difference between the testnet and futurenet? Thumbs up. And limitation and consideration for developers. So we also have to keep in mind all the limitations while you're developing on this network. You cannot develop an application that you want to run on the mainnet on the future net. Okay, moving to production. So there's stages that you have to take. There are stages that you take before you starting from creating your smart contract, testing it on the test net, or maybe you want to try new features on the future net, and then to move it to the mainnet. Transition from testnet, futurenet to mainnet involves changing network paraphrases and ensuring database reinitialization. So there are a few key differences when you're deploying to the testnet versus when you're deploying to the mainnet in terms of the code, right? What actually is going to be written on the code. So one thing that you have to know is the paraphrases. There's something that is called network paraphrase that is specified on your code on your smart contract to basically telling the smart contract to which network it should use. So this happens on the paraphrases. So this we going to see it in action when we start building, when we start coding and building smart contract. So before deploying to the mainnet, you have to test your smart contract. You have to audit your smart contract, and you have to make sure it does what it does, and then you can deploy to to the mainnet. Because you remember, because when you're in the mainnet, you're using real fund, you're using real resources that cost money. So yeah, thank you. Uh, this is we are at the end of our slides. Now we're going to move into something new, and this is our last slide for this module. I can call it a module of all this theory that we've been doing, because we've been speaking about. I introduced you to blockchain, and then I spoke about we spoke about Stellar Stack, and now we're going to move into our last part of this series, which is understanding the Stellar Consensus Protocol. Let me share the slides. Okay, before maybe I'm getting ahead of myself. Before I move on to the new topic, is there any questions? Is there any questions? And once we're done, I also want to let you know that once we're done with this series, I'm going to give you an assignment to do. And this is something that's also going to be happening when we start coding. So when we learn how to code, there's also going to be an assignment for you to take home. So keep that. Sydney? Sydney, you can go ahead. Can't hear you. I think you're still unmuted. You're still muted. Or you can type it out, and I'm gonna get back to you. Any other questions or concerns? Where do I get lost in recording? We have it in our Telegram. Let me just share the Telegram now. Let me just share it right now. We have it on Telegram and also on Discord. Just hold on. Let me get the link. Are you on Telegram, Sydney? Sydney, are you on Telegram? Because if you're not there, I can also. Okay, Discord. Okay, let me share it with you now. Oh. By the end of the session. Okay, let's move on. Uh, oh my goodness. Okay. Alrighty. So we're moving on to a new topic. Yeah. All right. So understanding the stellar consensus protocol. Before we start, can somebody just explain uh, what's the importance of consensus in blockchain? What's the importance of consensus? So we're going to talk about it here. So this is what we cover. We cover the introduction to the stellar consensus protocol, and then we get into the core concept of the SCP, stellar consensus protocol, the quorum set and quorum slices, node blocking sets, voting, accounting stellars, and trust lines. So this is the last uh, bit of information that we're going to get into. So why consensus is important in blockchain? Distributed monitoring and approval. So many computers approve each transactions. So in decentralized systems like blockchain, transactions are validated and approved by multiple nodes rather than single central authority. This ensures that no single entity has complete control of the transaction process. So this is multiple computers on the network have to approve the transaction. The second reason why consensus is important is decentralization. There's no single point of control, and by distributing the decision-making process across many nodes or many computers, the system becomes more resilient to failure and attacks. This is the fundamental principle of blockchain technology. So let's say you have 100,000 nodes that are running, and even if you destroy, out of those 100,000, you destroy almost all of them, and then you stay with 50, or you stay with two, you even stay with two computers, two of those nodes. Those two nodes still going to have a full copy of the blockchain. And the other reason is state synchronization. So everyone sees the same history. So consensus ensures that all nodes in the network have the same view of transaction history. This is crucial for maintaining the integrity and consistency of the ledger. And another reason why it's important, double spend prevention. Consensus mechanisms are designed to prevent the same digital asset from being spent more than once. Uh, this is achieved by ensuring that each transaction is recorded and agreed upon by the network. You don't want to be in a situation where you did one transaction and you're not really sure if the transaction went through, and then you do it again, and essentially double spending. So with consensus mechanism, it prevents that from happening, because you're going to know once you send something, when your transaction is confirmed, then you know for sure that you spend that money and nobody can cheat you from that. Another reason is enhanced security. By distributing trust among multiple nodes, the system becomes more secure against attacks. as it is much more harder for an attacker to control a majority of nodes because there's so many nodes running in different countries, different cities. So there's no way you can just destroy or you attack even multiple of them and destroy the whole blockchain system. So this is why consensus is important in a nutshell. So Stellar consensus protocol overview. Stellar has a very special consensus protocol when we compare it to other blockchain. And one of the so what makes it special, one of the things that makes it special is it uses a federated Byzantine agreement. So Stellar consensus protocol is built on this model. Something also, like yesterday, I recommended you to go read about. So it's based on the FBA model, which allows for a more flexible and decentralized consensus process compared to traditional models like proof of work or proof of stake. In FBA, consensus is reached through the cooperation of multiple independently chosen nodes or trusted nodes. And it uses also trusted node agreement. Each node in a Stellar network independently select a set of node it trusts. Consensus is reached when a sufficient number of these trusted nodes agree on a transaction. So you can also imagine that this helps with efficiency, speed, because you don't have. Let's say we have we have 50 we have 50 quorum sets. So each of those 50 quorum sets have, like, let's say five each. So it's 250 nodes in total. You don't have, not every trusted node have to agree before the node the blockchain can reach consensus. You just still just need a select number of nodes that are trusted, that are selected and trusted to agree on anything, like for example a transaction, for the transaction to go through. Just a sufficient number of those nodes. And decentralized control, there is no central authority that dictates which nodes need to be trusted. So this decentralized control enhances the resilience and fairness of the network, as no single entity can control the consensus process. So the core concept of Stellar consensus protocol, trusted nodes, Stellar core nodes. These are the validators in the Stellar network. They are responsible for validating transactions and ensuring the integrity of the ledger. So we know about these nodes. And the user-defined trust, each node independently chooses which other node to trust. This allows for a flexible and decentralized network where trust is not imposed by a central authority. And decentralization, by allowing nodes to choose their trusted peers, SCP promotes a decentralized and democratic network structure. So one way to explain this, and we're going to be more technical later, is let's say you have a class, and that class have an open book homework or open book assignment. But nobody knows for sure that their answer is correct. So the teacher said, okay, you can work in groups, But we in those groups they have only one person that has access to the other group. So basically, you have, let's say you have 5 people in a group or 6 people in a group, and then there's another group of 6 people, and another group of 6 people, another group of 6 people, and then they're given a homework or an assignment, uh, but nobody knows that they actually correct. They did the homework or assignment correctly, so they assign one person uh, that is trusted, that can also verify the other group to see if they are trusted, if they did their homework correctly. So let's say one person who's trusted goes to the other group and then meet the other person who's trusted, and they exchange answers, and then they'll say, okay, we since our answers are, like, compare the answers, and if all the answers are correct, they're similar, then they say, okay, we are correct, our answers can be trusted. So it's kind of a similar, so the decentralization, the stellar consensus protocol kind of work that way. So encouragement for validators, like I mentioned before, validators in the stellar network are not rewarded with monetary gains like proof of work or proof of stake. Instead, they are incentivized by the overall security and reliability of the network. Network and security contribution. So another encouragement for validators. So validators contribute to the network security by participating in the consensus process and ensuring the integrity of transactions. There's also the benefit of products and services. A secure and reliable network benefits all applications that is built on Stellar, providing indirect incentives for validators to participate. So any questions so far? Anyone has a question or concern? This is just an overview of the core concept of the SCP. We're going to dive deeper as we move along the slices. Here are the desired properties of a consensus mechanism. One of the core properties, the desired properties, is fault tolerance. Because when you're running a system like that, you want the system to be running 24/7. You don't want it to have downtimes. So there has to be fault tolerance, continued operation. The fault tolerance ensures that the system remains operational even if some nodes fail or behave maliciously. This is critical for maintaining the reliability of the network. And also resilience. So the network can withstand and recover from node failures, ensuring uninterrupted service and transaction processing safety. Another desired property is safety. Safety in consensus agreement, safety ensures that no two nodes accept conflicting values. So this is crucial for maintaining the consistency of the integrity of the ledger. And security. The security ensures that all the nodes produce the same transaction block, preventing any discrepancies or double spending issues. So you need to have fault tolerance, you need to have safety and liveness. Output all values. Liveness ensures that node can continue to process transactions and produce valid values, even if some nodes are not participating. This is important for continuous operation of the network. Operational continuity, the network can continue to function and process transactions despite some nodes being offline or behaving maliciously. So let's say we have 100,000 nodes, even if out of those 100,000 nodes, 10,000 nodes stop working, the blockchain is still going to work. The blockchain network itself is still going to work, even if some nodes start behaving maliciously. Stellar consensus protocol focus. It focuses on prioritizing safety and fault tolerance. It focuses on ensuring that no two nodes diverge in the ledger state and that the system remains resilient to failures. So the fault tolerance. Liveness is considered, but not at the expense of safety and fault tolerance. So liveness is also so important. It's one of the most important aspects of the blockchain itself, but it should not be on in the expense. Should not be in the expense of safety and tolerance. We about to end. Now let me check the time. Okay, I think we're going to stop here. Any question? Anyone has a question? Okay, so next week Monday, we're going to continue with this, and this is going to be our last theory before we get into coding, because I'm pretty sure a lot of you are waiting for that. And yeah, hopefully on Tuesday that's when we're going to start. But there's also going to be an assignment on Monday, and or Tuesday. I'm like, I'll give it to you on Monday or Tuesday, just to make sure all of you have an understanding of what we've covered so far.
Just a question. Thanks for tonight. It was pretty cool. The slides, like I'm not on Telegram. Would you be happy to share them on either WhatsApp? Or I don't know if you want to still share those links on how we can get to the Discord group and then share it there.
Yeah.
But I don't know, WhatsApp would be a lot easier if you don't mind sharing the slides so far that you've done because they're really
Okay.
good. So I just need to go through them again.
Okay, I'll show it to you. So let me now. I'll send the links on WhatsApp. I saw a message. Let me just read it. I can show you how to get on Discord channel. Okay, we're done for today, guys. Now I'm just going to look for the link, the Discord link, and paste it on the chat because my Discord was frozen. My Discord app was frozen. So here's the link. Boom. What else? What else? So I'm going to share the presentation on WhatsApp. Yeah, I guess that's all for today. Thank you guys. Thank you for being here today. I really appreciate it. And next week, same time, same place. Monday. First, we're going to meet on Monday, and then hopefully on Tuesday we start coding. We start getting our hands dirty. Good night.
Cool.
Thank you.
Bye, Ben. Thanks a lot. Enjoy night. Bye. Cheers, guys.
Bye. Let me end this video.